The traffic module is a decision support solution designed for railway infrastructure and rolling stock maintainers and managers. It monitors the condition of the equipment while assessing its impact on the infrastructure. By considering actual loads, it provides users with the information needed to adjust maintenance schedules for both rolling stock and infrastructure, thereby optimizing interventions based on real usage. To deploy geometry, we will need various types of data. Data from sensors installed in the field, such as weighing stations, accelerometers, switch motors, track circuits, and RFID readers. Information systems related to operations. Asset data related to mapping, including tracks and switches. The traffic module is structured around 4 tabs. Exploration, to view information on train quality and their routes on a given date. Train compliance for statistical details on their distribution. Train tonnage for details based on types of operations. Classification of tracks and switches according to their actual loads. The first tab, Exploration, allows you to view information on train quality and their routes over a given period. It includes a section with several key indicators related to line operations. These indicators can be customized according to the user's needs and constraints. The list of trains includes their passage dates and any non-compliance issues. It is possible to filter and display only the non-compliant trains. By clicking on a train, you can immediately visualize the route it traveled, including track changes at switches. In the columns, you can check the types of non-compliance affecting the train, such as flat wheels, ovalization, polygonalization, axle load, or load distribution. All these defects generate stresses on the rail and cause different types of wear on the infrastructure. By selecting the non-compliance visualization option, you can examine the train's composition in detail, analyze the forces exerted by the different axles, and precisely view the identified non-compliance. If some wagons are equipped with RFID tags, it becomes possible to track the evolution of their stresses over time, allowing maintenance strategies to be adjusted based on actual wear. The Non-Compliant Train tab provides a statistical overview of train non-compliance, offering a more general approach. This allows for a more precise evaluation of overall non-compliance volumes compared to the total number of trains. It also distinguishes between different types of non-compliance, including those related to axles or wheels and those linked to tonnage issues. This information is particularly useful for identifying whether the non-compliance consistently originates from the same trains or from the same responsible entities, such as the train owners. The tonnage of train operations impacts the infrastructure differently depending on the types of trains and their speeds. Our module will automate these sectoral groupings to better assess the impact on track aging and to alert us in case of significant changes in types of rail traffic. With information on train tonnage, different routes, and traffic categories, we can evaluate UIC groups on the maintainer's various lines, allowing them to adjust maintenance schedules according to the line classification. To do this, they simply select the time period based on their planning horizon. This enables them to adjust and prioritize interventions, for example, during strikes or significant changes in traffic types.